Okay, we'll get back to 4.1, 4.2, and then 4.4 is what I'll cover here in this video too. I was going to have us cover the rest of section 4.1 and 4.2, which is this page here. And so this just kind of got some notes on it. Researchers must understand the nature of a linear relationship between the response variable x and the explanatory variable y. And by the way, this terminology that you'll see in the book where they call x the response variable and y the explanatory variable. If a linear relationship exists between the two variables, the following ideas should be considered. So number one, there's a direct cause and effect relationship between the two variables. That is, x causes y to happen. So for example, water causes plants to grow, poison causes death, heat causes ice to melt. Okay, so that's one thing to consider is that what's the relationship between the two variables? Well, maybe one's causing the other one to happen. Another one is there's a reverse cause and effect relationship between the two variables. That is, y causes x to happen. For example, a researcher believes excessive coffee consumption causes nervousness, but the researcher fails to consider the reverse situation that may occur. That is, it may be an extreme nervous person craves coffee to calm his or her nerves. That could happen, right? So y could cause x to happen. The relationship between the two variables may be considered by, or may be caused by a third variable called a lurking variable. Okay, a lurking variable was actually mentioned back in chapter 1. I just chose not to talk about it though, since you really don't need to know it, what that is until now. But a lurking variable is a variable that was considered in the study, or that was not considered in the study. For example, the number of glasses of lemonade consumed daily in the summer can be used to explain the number of deaths due to drowning. Does this mean that the lemonade caused the deaths? Of course not. In this case, the lurking variable is the summer temperature, since both the variables are related to heat and humidity. As the temperature rise, lemonade consumption and deaths both rise, and deaths due to drowning both rise. Okay. In other words, correlation does not imply causation. Okay, that's very important. So it's not because, why isn't that happening because X? Okay, it could be, so these terms are different. Okay, here's an example. Problem 11. Based on data obtained from an almanac, the linear correlation coefficient between the number of television stations in the country and the life expectancy of the residents of the country is 0.713. That's a good number. So part A, do you believe that the more television stations a country has, the longer its population can expect to live? So are people living longer because there's more television stations available? No. Okay, but part B, what might be a lurking variable between the number of television stations and life expectancy? Well, wealth is a likely lurking variable. Okay, the more television stations a country has, the more wealthy it is. And the more wealth, the better the healthcare. Okay, so that's probably why these variables would be, why one would be correlated to the other one. Problem 12 is another example. In a study of 16 to 11-year-old elementary school children, researchers found a strong positive association between the reading level and the weight. Heavier children have higher reading levels. So part A, do you think the school should develop a strategy to help children gain weight in order to increase the reading scores? No. Part B, what might be the lurking variable in this study? Age is a lurking variable. Okay, heavier children tend to read better because they are older. Okay, so so the gap here. Yeah, 6 to 11-year-old kids. I mean, that's 6-year-old is what, kindergarten, first grade, to 11 years old. That's sixth grade. You know, so they're looking at all the all kids in elementary. Okay, age is the looking variable there. There may be a complexity of interrelationships among the variables. So, for example, a researcher may find a strong relationship between a student's high school grades and college grades, but there are probably many other variables involved, such as IQ, hours of study, influence of parents, motivation, age, instructors. Okay, lots of things would be contributing to a student's grade performance. And lastly, the relationship may be coincidental. So, for example, a researcher may find a strong relationship between the increase in the number of people exercising and an increase in the number of people who are committing crimes. Okay, but common sense would say that any relationship between those variables has to be due to a coincidence. Okay, so there's just because people are committing crimes, that has nothing to do with their exercise, right? Or vice versa. Okay, so here's the homework that I'd like you to look at in sections 4.1 and 4.2 in the book, and I had it planned where we'd cover 4.4 also. So this is the last page of the worksheet here, and section 4.4 is called contingency tables. A contingency table, also known as a two-way table, is a type of table in a matrix format that displays the frequency distribution of a variable. A contingency table can be an option to solve or to show a relation between two qualitative variables. Okay, so we just looked at a lot of examples of where the two variables are quantitative, or some exceptions where one variable is qualitative and the other is quantitative. Okay, now we're going to look at if two variables are qualitative. Okay, problem 13. In an effort to gauge how the country's population feels about immigration, researchers surveyed adult citizens, and one question asked, on the whole, do you think that immigration is a good thing or a bad thing for the country today? The results of the survey by ethnicity are given in the contingency table. Okay, so here's our table, and part A says how many adult citizens were surveyed. Okay, so if you add up all the columns and then add straight across, or add up all the rows and then add downward, you should get 790 total were surveyed. Okay, of this group, how many Hispanics were surveyed? Okay, so I add up the Hispanic column. 147 plus 33 plus 12 plus 6 is 198. Part C, what proportion of adults feel that immigration is a good thing for the country? Okay, so here's a good thing, the top row. So I want to take the top row and then divide by the total. So I take 484 and then divide that by 790, and I get to roughly 0.613 or 61.3%. Feel that that's a good thing. Okay. Part D, what proportion of Hispanics feel that immigration is a good thing for the country? Okay, so a good thing in Hispanic, so there's 147 individuals there out of the 198 Hispanics. So I would just divide those two numbers. 147 divided by 198 is approximately 0.742 or 74.2%. Feel that's a good thing. Okay. Problem 14 is the the last one here. The Pew Research Center for People and the Press conducted a poll in which it asked individuals to disclose their level of education and feelings about availability of abortion. The contingency table shown below is based on the results, it should say, of the survey. Okay, so I've got, here's my contingency table, and how many individuals were surveyed? Okay, well, 833 is the total that were surveyed, so I can either add, add straight across to get these four numbers and then add down, or add these three numbers here to get the totals and then add straight across to get the grand total. How many college graduates were surveyed? Okay, well, so I take the total there in the last column, 276 were surveyed. Part C, what proportion of college graduates feel that abortion should never be permitted? Let's see, never permitted and college graduate, there's 17 of those people. And then divide by the number of college graduates. So I take 17 divided by 276, and that's how many college graduates feel that abortion should never be permitted. Roughly about 0.062, or 6.2%. Part D, what proportion of those who feel abortion is legal, with a few exceptions, have some college education? Okay, so I look at this row here, and then this column. So there's 94 individuals that were surveyed that have some college and feel that abortion is illegal, with a few exceptions. Divide by the total in that row, so which is 288. Okay, so 94 divided by 288 is roughly 0.326, or 32.6% have those feelings. Okay. All right. So I'm all done here with what I'd like us to cover in Chapter 4. We did not cover Section 4.3. And here's your last homework assignment in Chapter 4. Be sure to look at that. Okay.